Welcome. Good morning and good afternoon. As we know, it depends on where you guys are located today. My name is Robert Nelson, and I'm the Mobility Segment Growth Leader for Amco Polymers, and will be your moderator for today's seminar. Also with us from Amco Polymers is Bruce Serafin, our Mobility Segment Leader. We're both happy you're able to join us for today's seminar, which is Charging EV Development with Advanced Thermoplastics, presented by the SABIC Specialties business. Go to the next slide, Brian. Okay, just a little bit of business to take care of up front here with this slide. I'll give you a chance to take a look at it and review it. There will be a question and answer session at the end of this presentation, but please use the chat feature to log your questions as we go through the seminar, and we'll answer as many as we can during that time frame at the end. Please note, if we don't get to your question during the session, we'll follow up by email after the seminar. I'd like to take this opportunity to introduce our presenter for today, Brian Vestuba from the SABIC Specialties business. Brian is a Senior Business Manager for Mobility and EV at SABIC Specialties. In this role, he is responsible for the America's EV strategy development, which includes both application and business development. Brian has served in various technical and marketing roles for SABIC, and prior to SABIC, he worked 10 years within the automotive industry. Brian earned his plastics engineering degree from the University of Massachusetts Lowell and has 25 years of plastics industry experience. Welcome, Brian, and thank you for your time and support today. It's all yours now.
Thank you for the introduction, Bob. I'm happy to be here today. I want to thank you all for joining the SABIC Specialties webinar. I also want to thank Amco Polymers for sponsoring the event and inviting us all to be here today. The EV battery brings along several new and interesting challenges for us as material innovators. Complex electrical systems are replacing traditional fuel tanks at an ever-increasing rate, demanding materials that are safe and with the proper functional performance. Today I'll start with a quick introduction on SABIC Specialties. This is followed by a look at industry trends, a regulatory review. This part will help us into the next section, in which I'll discuss applications, challenges, and possible solutions. We're part of SABIC, one of the most diversified businesses in the chemical industry and a leading global player. The specialties business is SABIC's home of unique offerings. Our portfolio comprises of high-performance resins, compounds, and additives, combined with world-class application technology, expertise, and deep customer intimacy. Let's take a look at some of the industry trends. EVs are expected to see tremendous growth and already have in some regions. Industry analysts predict that by 2030, 30 million vehicles will be electrified, including both full battery EVs and hybrids. That is a 26% growth rate. Approximately 11 million EVs will be produced in Europe, 5 million in the US, and the remaining 14 million in the rest of the world. The combustion engine is not going away in the relatively near future. However, investments will be moving from combustion engines to EV. Battery systems will rapidly evolve to keep up with the regulatory performance and customer expectations. Plastics can complement this due to the inherent design freedom offered, for example, part consolidation and complex geometries. The EV battery will undergo a range of advances in the coming decade that will not only serve to improve battery performance, but which will assist EV OEMs in reducing overall system costs. Following the development of a native EV platforms designed exclusively with electrification in mind, we'll see a gradual transition towards a cell-to-pack or fully structural battery configuration that maximizes the system energy density while affording various improvements at the vehicle level. To alleviate some of the concern regarding consumer range anxiety, we may see system voltages and energies universally increase to enable efficient, high-power charging and increased driving range. Of course, consumer mindset may necessarily change, while the availability of EV chargers themselves will be essential to the growth of EVs. In this respect, numerous OEMs and utilities are emerging to fill the void. Perhaps the biggest advance will come with the introduction of non-flammable solid-state batteries that offer significant promise in terms of both safety and performance. Following their introduction, we may see the emergence of smart sensing, self-healing batteries that will reduce the instances of failure and improve the longevity of the battery for EVs and so-called second life battery applications. To meet the expected demand for EVs in the future, significant investment is required in the coming decade, not least in annual battery production. With transportation of lithium-ion batteries being a challenge, numerous cell manufacturers are working to expand local production capacity in close proximity to their customers. Europe, in particular, is expanding cell production capacity at a significant rate. According to McKinsey, it's expected that demand for EV batteries in Europe will reach some 1.2 terawatt hours annually by 2040. While the majority of vehicle OEMs will continue to purchase cells from reputable suppliers, others have announced JVs, and a growing number of OEMs will opt for in-house cell production. Such moves require substantial investment in terms of CapEx and knowledge, yet underscores a commitment to an all-electric future. I'll not go into a lot of details on the regulatory aspect, because this is still an evolving space. Each region, sometimes even country, develops its own requirements, but it's important to mention that all of them have the intent to make cars safer. I do want to speak about regulations around the battery space. As for the batteries, the various standards all focus on fire safety, including thermal management, electrical safety, and impact resistance. One common test requirement that is described in all standards is the external fire exposure test, which is a very stringent test to pass. SABIC has the regulatory understanding to help customers navigate and find materials to meet their regulatory requirement. Together with Amco Polymers, we can provide support to you and your company in this area. One could say two worlds are coming together in this revolution. The traditional automotive market, based on a combustion engine, started back in the 19th century. Since then, the industry has seen a lot of changes. For example, the efficiency and power of the engine, computers tuning or optimizing the performance of the car, the protection of the passenger, and the aerodynamics. SABIC Specialties business has been contributing to these developments and evolutions for decades. For example, SABIC drove the development of the thermoplastic fender and body panels in the mid-1990s, thus reducing the weight, improving fuel efficiency, and maintaining passenger safety. Plastics can also provide design freedom versus steel in applications such as a tank flap or now charge port covers. Like automotive, SABIC's materials have been used in the electrical market for decades. This is a large and wide space with hundreds, maybe even thousands of different applications and products. It's also a very regulated market to protect the end users of these products. UL, IEC, and other regulatory bodies all contribute to the safety of these products. SABIC's been helping customers meet standards and regulations, allowing improved safety. SABIC can now combine these decades of experience and knowledge to develop new solutions for the electrification of the automotive market. Our offerings can help address complex requirements. Norel resins are a family of blends with modified polyphenylene ether, or PPE resin, delivering exceptional dielectric properties, dimensional and hydrostability, providing design advantages and performance stability. Norel products have relative low densities compared to many other compounds with similar properties, which helps with cost efficiency. Finally, the Norel portfolio only uses flame retardants that do not contain any chlorine or bromine. With our LNP copolymers and compounds, we compound the solution to our customers' challenges with unique combinations of resin systems, copolymers, fillers, additives, and flame retardants, delivering mechanical, optical, electrical, and thermal properties. As this portfolio is so broad, cost-effective solutions can be found for low temperature applications, as well as tough mechanical challenges for materials with high modulus ductile properties. Let's now dive into the battery applications. Depending on the design, battery modules require suitable enclosures to protect cells and electrical components from damage, unwanted contact, and exposure. Today, you'll find many examples of such applications using SABIC Specialty solutions. Enclosures need to be mechanically robust and flame retardant to meet various module and system level safety tests. Materials used should be lightweight, highly processable, and compatible with secondary operations such as UV adhesive curing. For module enclosures and mild hybrid battery housings, we offer materials bringing a balance of excellent mechanical properties and ULV0 performance. Where superior flow for thin wall parts is demanded, like a module cover, we propose unfilled compounds with excellent chemical resistance and thin wall ULV0 performance. To prevent the movement of modules during vehicle operation, fixtures and brackets need to show ductile impact behavior combined with, again, ULV0 performance. On this page, I'm showing 4 candidate materials together with the respective application. The first 3 materials belong to our Norel product family, which consists of a blend of polyphenylene ether and either polystyrene or polyamide. Highlighted in the blue are some standout features of these materials, like density, the comparative tracking index or CTI, and UL94 performance. NHP 5040 is a glass-filled PPE compound with V0 at 0.75 millimeters, making it one of the best in its class. It's widely used where high stiffness is required. NHP 6011 was recently developed for such applications. Is an 8% glass-filled material with lower density, ULV0 performance at or above 1.5 millimeters. Cycloase CX7240 is a blend of polycarbonate ABS and a polysiloxane copolymer, which brings additional low temperature impact performance and chemical resistance versus typical PC ABS grades. It's important to mention that due to the amorphous character of the materials shown, they offer excellent dimensional stability over wide operating temperatures and bring long-term performance to critical applications within the battery. Of course, the grades mentioned are just a selection of our overall portfolio. Where the existing offering cannot cover your needs, our dedicated technology teams can work with customers in developing materials aligned to your individual requirements. Our SABIC technology team tested Norel resins along with competitive materials. On this chart, you can see the attributes required for EV battery applications. First, due to their low density, Norel resins contribute to a compact and weight-saving battery design, which can enable greater energy density via part integration without sacrificing safety or processing performance. Second, chemical resistance against electrolytes and cooling fluids. As these parts are near to the active components, it's something that needs to be considered. As shown, Norel resins offer excellent resistance to battery electrolytes and also to coolant fluids like ethylene glycol. And the third point is flame retardancy. With non-halogenated flame retardants, these grades achieve robust, thin wall ULV0 ratings with the stiffness and impact resistance to enable the design of lighter, thinner, and more crash-resistant battery modules. Now let's look at some of the module applications within the battery pack. Depending on cell format, configuration, and system design, there are a range of module applications where the properties of specialty thermoplastics are desired. Here I show some possibilities, including pouch cell frames, bus bar holders with Norel resin, and cylindrical cell retainers using LNP thermocomp. Applications such as those I've mentioned have a wide range of material requirements that are evolving to meet the growing demands of next-generation battery systems. Due to the range of battery designs, our customers in this segment have differing requirements, but there are certain commonalities. Typically, we see a common trend towards V0 flame performance at 1 millimeter or even below. This is an increasing requirement for the V1 performance demanded in the past. In addition, we see wall thickness decreasing from 1.5 millimeters to also under 1 millimeter as system designers seek to reduce component size, enabling maximize energy density. Such moves are in combination with requirements for electrical tracking resistance and enhanced material flow to aid processing. Because retention of design is crucial in a tightly packed environment, our materials that offer excellent dimensional stability over semi-crystalline alternatives are increasingly demanded. Here I'm showing 3 grades meeting the requirements based on our experience in production applications. If you have a look at the blue highlighted data, you can see several performances that show outstanding behavior. Flame retardants at low wall thickness and superior flow providing low warpage. 2 of these I'd like to highlight. Thermocomp 9F005P is a compound based on a polycarbonate blend. We're seeing a trend in the EV battery space that these parts require transparency for the UV curing of the glues used to fix the parts together. In addition, this grade has a low CTE that's close to aluminum and a high flow, which makes it suitable for exceptionally large parts with small cross sections. The other grade is NHP 6012 on the right side, a new glass-filled compound that has properties to be used in bus bar applications. These materials are commercially available. However, we are constantly developing new solutions to meet new customer requirements. For example, a new experimental material is being tested as we speak with even better flammability properties. Coming back to the benchmarking chart, also in the module space, flame retardants is a major topic. As I already touched in the presentation so far, our products can provide the needed performance for these applications. The Norel NHP resin portfolio for electric vehicles is optimized for battery-related applications. These NHP grades, combining the inherent benefits of polyphenylene ether resin, like good electrical properties, excellent hydrolytic stability, long-term dimensional stability, low specific gravity, and acid resistance, with the impact resistance and processability of a high-impact polystyrene. Norel resins can offer excellent performance while meeting your costs and processing needs. Of course, the final material choice is dependent upon our customers' consideration of their own individual requirements and part performance testing. As experts of our specialty resins and compounds, our business is here to assist you in numerous ways, some of which include support for material selection and computer-assisted engineering. We'd be happy to work along with you and Amco Polymers to help determine the optimum specialties resins for your applications. The result? A lightweight battery enclosure having excellent electrical and mechanical stability added to the chemical resistance and flame retardants. Now we'll talk a bit about crash protection. Today's solutions are typically steel or aluminum. SABIC has developed a metal plastic hybrid honeycomb structure utilizing Norel GTX due to its balance of heat resistance, low temperature ductility, and flow. This solution can either be mounted as part of the battery pack or inside of the rocker and thus becoming part of the body in white. To be able to protect the battery during a side impact, the part needs to absorb energy over a large temperature range from -30°C to 80°C. So the strength and impact performance of the material needs to be stable and robust. In fact, Norel GTX is one of the only plastic material to pass the impact test at -30°C with 100% ductility. If part of the body in white, the hybrid solution needs to withstand the E-coat treatment, which can see temperatures greater than 180°C for over 30 minutes. Norel GTX has proven to be up for the challenge, not only meeting the impact requirements, but also saving weight and reducing costs compared to steel or aluminum. This video shows the vehicle level side impact rigid pole simulation and the resulting data from the simulation compared to the incumbent aluminum. SABIC has simulation capability and material cards with high-speed data to help customers in their design and development of crash protection structures. On this chart, you can see the various attributes required for side impact crash protection, such as -30°C impact strength and the ability to withstand E-coat. The Norel GTX resins is an excellent candidate for crash protection. As you can see on this illustration, SABIC has a material for many applications within the battery. I highlighted a few applications today that I felt are innovative solutions to the new challenges being presented to the EV industry. Now we'll move into supply equipment. Reliable charging stations and components for home and public use can help expand the EVSE network and promote consumer adoption of electric vehicles. SABIC specialty materials can provide excellent impact performance, weatherability, and chemical resistance, helping manufacturers create safe, long-lasting supply equipment to support the expansion of the charging infrastructure. Supply equipment applications have some demanding requirements, such as UL94 V0 or even 5VA for the body panels. The handle should provide good low temperature ductility to meet customers' impact and drop tests. Chemical resistance or outdoor weathering may be critical depending on the use location of the equipment. SABIC Specialties conductive Norel GTX resins have long been utilized in tank flap and now charge port cover applications. Norel GTX can be electrostatic painted and has the stiffness, dimensional stability, and the high heat capability required during e-coat and or paint bake, depending on your process. GTX 973 offers best-in-class performance for charge covers. As EV charge covers are typically larger than fuel filler doors, we have developed Norel GTX 989 with higher flow for larger parts with improved impact resistance. EXL 9330 is an opaque polycarbonate siloxane copolymer resin that offers extreme low temperature ductility in combination with excellent processability. This UV stabilized medium flow resin features ULF1, V0, 5VA ratings with non-chlorinated, non-brominated flame retardant agents for a wide range of colors. The EV charging station requires durability in a wide temperature range from low temperatures along with the higher operating temperatures for the charging operation. I highlighted EXL 9330 for the handle. Here it's being used on a public charger housing. EXL 9330 enabled the OEM to achieve the hardware durability requirements over a wide temperature range of -50 to 90 C. EXL 9330 outperformed glass-filled PBT and impact modified polycarbonate due to its superior impact performance and ability to pass a vandalism test. EXL 9330's F1 5VA rating combined with GWFI greater than 750 C met the demanding weathering, FR, and electrical property requirements for this outdoor public charging station. Here I'm highlighting two of Specialties high gloss molding color UL94 flame rated solutions. A molding colored solution provides a cost savings, plus these grades provide a balance of impact, FR, heat, and weathering requirements versus parts that were previously painted. The EXL 9133 offers a unique combination of low temperature, impact strength, toughness, with sufficient heat performance. It offers consistent color aesthetics, a V0 flame rating for the powered components, a F1 rating for good weathering, and UV performance without hard coating. The CFR 7431, also F1 rated, V0 5VA rating, with the transparency for clear lens components. Both resins were chosen as the material of choice as it performed better versus standard commodity-based material that were in the evaluation. Now we'll move into some sustainability. Sustainability is not new for the Specialties business, as we have a history of more than 30 years working on solutions to lower carbon emissions. We started our journey in the 90s focusing on usage of post-industrial recycle and waste and water and energy reductions. We followed this with many programs around open loop and closed loop recycling. We introduced new resin based on chemical upcycling of PET to convert it into more durable PBT and also commercialized products containing renewable content from castor oil. We've designed our products to be environmentally friendly using non-halogenated flame retardants and additives. They find use in electric vehicles, photovoltaic assemblies, and in helping customers design thin wall products. We continue to build on these offerings, but also look forward to use of bio-based feedstock in our products and support design for recycling efforts while ensuring that we are following the principles of responsible sourcing in our value chain. At SABIC, the United Nations Sustainable Development Goals, or SDGs, are linked to the company's strategic priorities. Here I'm highlighting SDG 13, climate action. Our family of LNP functional compounds and Arel resins contain up to 80% post-consumer and post-industrial mechanically recycled contents. According to internal life cycle assessment studies, these materials with mechanically recycled content can contribute to almost half of CO2 reduction in comparison to virgin feedstock, subject to the amount of recycled content present in the material. As I mentioned, SABIC developed a proprietary upcycling technology, LNP Elkrin IQ, which uses chemical depolymerization to process single-use PET bottles into PBT resin. LNP Elkrin IQ portfolio contains up to 60% of post-consumer recycled content and weight, and is a drop-in solution for conventional PBT processing. SABIC's LNP portfolio contains more than 60 grades using second-generation feedstocks, such as hydrotreated vegetable oils, which do not directly compete with the food chain. These bio-based materials carry the International Sustainability and Carbon Certification and can contribute up to 61% of the CO2 reduction while offering virgin quality and consistency, and can qualify for REACH and RoHS compliance. Specialties mechanical recycling portfolio could provide benefits such as tailored post-consumer recycled content by the formulation design, included EcoFR for thin wall applications, carbon footprint and waste reduction, offering similar properties, performance to virgin grades, and drop-in solutions to existing tools. As we continue to develop new products, we have the possibility of adding recycled fillers like glass or carbon fiber. We currently offer more than 20 grades in our portfolio using post-consumer recycle or PCR polycarbonate. It includes structural portfolio for lightweight, thin wall applications, which can provide high stiffness by using 10 to 50% glass fiber reinforcement. DXL compounds provide low temperature impact down to -60°C while containing up to 80% PCR content. The CX portfolio offers excellent processability with PCR content ranging from 30 to 50% while offering good impact, improved flow, and FR properties. Our Elkrin IQ technology is used to upcycle single-use of recycled PET water bottles into PBT polymer. The recycled PET depolymerization product is then repolymerized to PBT using a SABIC patented technology. 60% recycled content in the PBT polymer backbone is extracted from recycled PET. Through the chemical operation, currently we can handle PCR PET feed streams from ocean-bound and land source. To better provide the waste stream transparency, we also spent extra efforts to have responsibility certification verified across the entire value chain. To date, over 100 million single-use PET bottles have already been diverted, with an ambition to achieve 10 billion by 2030. When compared with conventional PBT compounds, Elkrin IQ PBT technology provides environmental and social benefits while maintaining good quality. When compared with mechanical recycling, the chemical recycling technology further removes the negative effects from post-consumer use and can offer better quality and colorability. UL's recognition of existing virgin material can be extended to its chemical recycled version provided they are chemically identical. This simplifies UL's recognition process of IQ PBT Elkrin grades that are based on existing virgin PBT grades. Currently, we've developed 15 Elkrin IQ compounds to provide the PCR content range from 12 to 56%. This technology exists in PBT and PBT PC compounds, which has many applications within automotive, such as crash protection, connectors, and various other components. The products could provide many different attributes. For example, thin wall FR, lubricated to improve wear and friction performance, good impact, high ductility, and excellent surface aesthetics. The portfolio is continuing to grow and expand to meet various market and application needs. This represents a manufacturing scheme for the bio-based offerings. On the left, you can see both bio feedstock and fossil feedstock come together to be in as part of the conversion and compounding, ultimately resulting into the final products. Again, this is renewable feedstock derived from waste or residue. The reduction in carbon footprint can be up to 61% by using such feedstocks. It's important to note that currently today, LNP copolymer resins, LNP PC compounds, and Ultem resins are all offered in bio-based offsets. Norel resins are currently under development and should be commercial soon. When compared with conventional or mechanically recycled compounds, our bio-based resins offer the same product and the same properties. Therefore, your part requalification may not be required. As you can see, the better carbon and energy footprint, obviously avoiding some fossil depletion. The color space is wide open and can provide virgin quality material. This graph positions the relative physical property performance to the aesthetics and color capability of recycled and renewable materials according to the type of recycling technology. Thanks to a combination of proprietary recycling technologies, responsible sourcing, with compounding excellence and color capability, we can deliver materials based on recycled or renewable content with the same performance as those based on virgin feedstock. These can be suitable for high performance applications, now with the additional benefit of contributing to the manufacturer's net zero carbon ambitions. Using this illustration of EV battery charger, I wanted to demonstrate how we've been designing for sustainability, using solutions like Elcrin IQ resin or LNP SLX compounds produced by using a renewable feedstock. We could work together and develop a similar solution for the EV battery or EVSE applications we have reviewed earlier. Again, please help us understand your needs in this area by contacting either Bruce or Bob at Amco Polymers. I'll now touch on a few upcoming innovations from SABIC. We're developing a thermoformable insulation sheet made of Norel resin that provides a safe and affordable solution for battery cell protection. With a robust FR, CTI 0 high tracking index performance, the sheet could prevent the battery cells from ignition and electrical breakdown issues. Traditionally, metal is used for such protection, which is heavier and more expensive to make than via using a thermoform Norel sheet. If you're designing a wireless battery management system, consider LNP conduit compounds. These grades offer thermal conductivity, are electrically insulative, non-brominated, non-chlorinated FR grades. These conduit grades are also RF transparent to allow for wireless communication. Honeycomb structures possess unique properties such as rigidity and energy absorption that can add value by protecting EV batteries from impact. Econ Core has developed new honeycomb cores for laminated sandwich panels using SABIC's Norel GTX resin, which delivers higher heat performance and better dimensional stability than traditional thermoplastics. The cores can be combined with thermoplastic skins to produce recyclable sandwich panels. I quickly wanted to highlight the 4 key messages for you. EV battery space is growing fast with lots of new investments. Regulations are still evolving, especially considering the safety requirements. SABIC Specialties has proven solutions available and is constantly developing new materials that can provide safety, performance, sustainability, and cost efficiency. SABIC is always looking forward to working together to solve these challenges. And with that, I'd like to say thank you.
Okay, I think thank you very much, Brian, for all that information and detail. What we'll do is switch over now to our question and answer session. If you've got any questions from today's presentation, please use the chat feature that's available on the meeting. But I also have some questions that we commonly get when we do these types of presentations that I think are interesting enough for the audience, Brian, that I'll shoot you a couple over to you. And I think you have somebody else. I think Ralph is with us as well.
Yeah, I've asked Ralph, my colleague Ralph Bonacati, to join us today to help. Just a quick intro for Ralph. Ralph's been with the company for over 30 years, starting off in manufacturing, moving into application development. For over 25 years, Ralph has spent his time focusing on regulatory and standards development. So Ralph, thank you for joining.
Well, like any good coach, let's get Ralph right in the game right now. So Ralph, can you talk about regulatory trends that you see emerging in this space?
Sure, Bob. Thanks. In the U.S., when you say regulatory, I think NHTSA, and NHTSA is not showing any signs of changing their battery requirements, at least in the near future, and they may not ever do it unless there are problems with the batteries that set themselves apart from typical problems encountered in automobiles. From a standards development side of things, the type of development we're seeing for batteries in particular is maybe more of a focus on thermal runaways, preventing thermal runaways. Besides that, electric vehicle supply equipment seems to be in like a continuous development mode, but I know that's not necessarily specific to the batteries. I guess on a state level for regulations, what you're seeing really is maybe a focus on recyclability coming from California and their lithium ion battery recycling advisory group activity.
Okay, thanks, Ralph. Another question that we've got, we see there's one queued up here from the audience. We'll get to that in just a second. But this probably goes to you, Brian. Do you have experience with secondary operations with your materials like laser welding, UV curing, and other type of operations?
Yeah, thank you for the question. Our business has a long-standing tradition of supplying materials compatible with numerous secondary operations, such as UV curing or laser welding. For EV battery and, for example, cylindrical cell retainers in particular, we've worked with external suppliers to validate the performance of our LNP CX7240 in UV adhesive curing. With respect to laser welding, what's important here is the level of near infrared transmission or absorbance depending on the part. Good news, amorphous thermoplastics typically offer higher transmission to near infrared radiation than semi-crystalline polymers, but the level can be affected by fillers such as glass or colorants. Depending on the grade and the exact application, we can work with your customers, Bob, and find the improved welding and capabilities or compatibility. Excuse me.
Sure, and what I think we could all agree is that each application has its own requirements, right? And we've got extensive capabilities between Amco and SABIC to help the customers get through those type of understandings and solutions. So thanks, Brian. Over to a question from the audience. This goes over to SABIC and such, but what are the current lead times on Narelle products?
Bob, that's actually a great question that I do not have offhand. So I apologize for that. I don't have that offhand.
I can answer that some, as we are a distributor for the resins. So there's some products that are readily available through our distribution system. Typically, though, Norel has been tight, like other resin products that are out there. We've put stocking programs together for our customers, but we also have customers that want to order it directly or brand new orders right now. And we're seeing, anywhere from 6 to 12 week lead times, depending on what products. So my suggestion would be is get a hold of your local SABIC rep or get a hold of your Amco Polymers salesperson or seller. And we can narrow it down based on the products that you're looking for, Carl, and get an answer directly for you on that. Okay. Okay, so Matt has a question. What are the typical additives that go through processes with EV polymers?
The typical additives, I think, as you heard multiple times, FR is critical within the space. Depending on the part requirements, could be glass fibers or other fillers. But I think those would probably be the two biggest that jump to front of mind for me. Would be the FR or stiffness requirements. Of course, we do have other additives, whether, if it's like a plug or socket, we can do things for lubricity, reduce the wear or efforts to plug and unplug something. We have additives for conductivity. We have, through the LNP compounding. I've always said, really, you can, if it goes in plastics, we have it, and we can really mix it up to meet customer requirements.
Great. If there's other questions from the audience, keep them coming. I have another one, and this probably goes again to you, Brian, but why is it so important to have a material that can withstand such a large temperature difference for a crash protection system that you were talking about?
Yeah, that's a good question. Not sure, everyone on the phone here, but, common automotive temperature range is, minus 30 or 40 C to 80 C. So essentially that range needs to be covered. And then when you come into the manufacturing, the example I was talking with the Norel GTX, if that's, part of the body in white, it's got to go through the e-coat bath and curing, which, can be somewhere between 180 to 200 degrees C. So, the not only the use environment, but the manufacturing environment is what, defines that widespread of temperature range.
One of the things that when I saw that you give a similar presentation, there was a couple of questions on, can you be more clear on when you were talking about the two worlds coming together, and just reiterate some of that for the audience?
Sure. The electrification of the vehicles is really combining electrical and automotive applications into one. Automotive engineers have never really haven't had to worry so much about the electrical requirements in the past, or the regulatory requirements like UL or IEC. And then, what happens when a vehicle's left plugged in one's home in the garage overnight? This now is an electrical device. So and automotive engineers have not been faced with that before. The electrical industry may not have needed to worry about things like operating over such a broad range of temperature, or cold impact, or such high levels of force, or like vibrations from driving down the road. So I feel we're in a strong position because we get to use our combination of experience in both industries pulled into one solution for EVs.
Great. One other question, again, these are from my notes of other discussions we've had, but people were really interested. But can you elaborate a little bit more on the new Norel NHP grades and why they're so important?
Yeah, as I mentioned, these were recently commercialized. This is the Narelle NHP 6011 and NHP 6012. Both these resins provide best-in-class non-chlorinated, non-brominated flame retardancy to meet UL 94 V0 requirements at 1.5 millimeter. In addition, they offer high stiffness and good impact strength for crash protection. In addition to these outstanding mechanical properties, both grades provide excellent resistance to acids versus a material like polycarbonate, better resistance to moisture compared to polyamide or nylons, and a low specific gravity. The two products differ in their glass roading to accommodate specific customer requirements depending on the stiffness needed.
Gotcha. Another question from the audience. What type and grade of resin have you seen been used in cell frame pouch battery modules?
In the cell frame pouch, again, we've used some of the Narelle products in there. I'd have to jump back to the specific grades mentioned in the presentation, but it's always challenging to answer these types of questions. I showed one grade of Narelle in the presentation, but depending on the specifics of the application, it can vary whether it needs more stiffness or more ductility, right? And which is why, like grades like the NHP series that we released, we have the different glass loadings depending on the particular application and customer requirements.
Yeah, it's safe to say, Brian, that basically we understand the requirements from the customer and then dial in the properties and the products.
I think that's a great way to say it. Yeah, as the dialogues with customers, continue, we both learn more. But from those dialogues, that's where we can narrow down the portfolio to help define the candidate grades that should be included for evaluation.
Well, great. Well, just a few comments to wrap it up here. You can see both Bruce and my contact information. If you would like a copy of this presentation or a copy of this recording of this seminar, please send us an email and we will make sure that gets out to you. And would like to thank Brian, for everything that you did today and your presentation. Ralph for being here to support us as well. We've got a great partnership with SABIC Specialties business, and they have lots of products and technologies that we can make sure that we share with our customers, and just appreciate the support today. With that, I think unless there's anything else that you need to add, Brian or Ralph, I think we'll wrap it up at this point.
Excellent. Thank you, everyone, for your time. I appreciate the chance.
We appreciate everybody's time today. Thank you, and enjoy the rest of your week.